Hello dear students, this is Mr. Muhammed Azeez. Previously we stopped on question 12, and in this lesson we're going to explain the relation between the second derivative and maximum minimum. Sometimes they are called maxima minima. They are just maximum minimum or max or mean. Okay, what is the relation between maximum and minimum with the second derivative? Let's look at this note. In this note, we say if f double prime is positive, definitely if f double prime is positive, the function is going to be concave. And if the function is concave, the point that is critical in a concave region is going to be minimum. That means concave always produces minimum. Minimum is the middle of concave. And if f double prime is negative, the function is going to be convex, and convex is creating maximum. Okay, keep this in mind. If f double prime is positive, we're going to have minimum. If f double prime is negative, we are going to have maximum. And if f double prime is 0, obviously, then the point is going to be point of inflection. Now let's solve these three questions using this idea. Although using this idea is not mandatory, you know, there is the other way we studied in section 1, the way of finding maximum minimum. We find first derivative equals 0, find critical. We do need to do the same steps until we find the criticals. Here, instead of making the table and using test numbers, we use the second derivative test to find the critical is maximum or minimum. This way is not very efficient to find intervals of increasing or decreasing. Whenever you find this way confusing, just go back to the ordinary way. All right? But that's not something to ignore. It is something that every student needs to know before entering Wazari, because there have been questions that forcing you to use this method. They give you second derivative. They give you a function that contains unknown. They give you critical. Then to check if the critical is maximum minimum, we need to use second derivative if there is no any other way. Now let's solve the first one. Question 12. Let's take it to the notebook. Yeah, some adjustment. It's good to go. Okay, firstly, if I want to find maximum minimum, I need to find critical value. Critical value is f prime equal to 0. Derivative is 4x power 3 minus 12x power 2. Derivative of two derivatives of constants are 0. Here, this is the first derivative. Equalize this to 0. 4x power 3 minus 12x squared equal to 0. Divide everything by 4 because why not? It's divisible. That's going to be x power 3 minus 3x squared equal to 0. Both terms are divisible by 4, so if I divide it by 4, it will look easier. Now take x squared as common factor. That's x power 3. This is x power 2. They are both containing x squared. Now if x squared went out as a common factor, what's remaining here is x minus 3 equal to 0. Now we have 0 product. If x squared is equal to 0, x is going to be 0. And if x minus 3 is 0, x is going to be 3. Now these two values are critical values because I got them from derivative equal to 0. Now I can check these criticals for maximum minimum using second derivative. This is the first derivative. Based on this, second derivative will be like this, 12x power 2 minus 24x. This is the second derivative. Now, second derivative of 3, f double prime of 3 is 12 times 3 power 2 minus 24 times 3. 12 times 3 power 2, it's 12 times 9 minus 24 times 3. That's obviously positive. but in exam, just use calculator. 3 power 2. You don't have time for silly mistakes. 36. The 36 is not important, the sign. That's positive. If f double prime is positive, that means f is concave. And as you know, concave produces minimum. That is telling me x equal to 3 is critical value and it is going to be minimum. X equal to 0, let's check f double prime of 0. It's going to be 12 times 0 squared minus 24 times 0, that's 0. When I get 0, I cannot decide if this critical is maximum or minimum. It is just inflection. And listen to this. Point of inflection cannot be maximum or minimum. It could be critical, but it cannot be maximum or minimum. Because as you know, maximum and minimum are in the middle of the region of concave or convex. So concave, convex, in the middle, we have maximum, minimum. Maximum, minimum cannot be point of inflection. But if we have a graph, let's say something like x power 3, this graph, or x power 1 over 3, this is x power 3, this point is critical, but it is not maximum or minimum. This point is fine to be inflection, which is indeed point of inflection, but it's not maximum or minimum. But for example, if we look at another standard N shape, this is minimum, this is maximum. None of them is point of inflection. Point of inflection is right here, it's in the middle. Okay, now question 13. This question, solving this question is graphically is the best way. Solving this question graphically is the best. Why? Because its graph is extremely easy. That is x minus 5, it's going to the right 5 steps, and there's a negative, the graph is upside down. 1, 2, 3, 4, 5. The graph is here, went to the right 5 steps, and it is upside down. Now if I want to find increase, decrease, I can find all. And if I want to find critical, this point is critical, and the critical is maximum. The point 5, 0, when x is 5, y is 0, is going to be maximum without using first derivative, second derivative, table, whatever, because its graph is easy. Same thing goes to 14. 14 is sharp corner. Sharp corner, the graph is very obvious. That's a sharp corner. Minus 3, the sharp corner goes down 3 steps. Then 1, 2, 3. The graph starts right here and goes like a sharp corner. Then again, solving this question 14 graphically is way easier. If I want to find interval of decrease, that's negative infinity 0. Interval of increase 0 infinity. And if I want to find critical, this critical value is minimum. It does have critical, it has no inflection, it has no concave, it's convex, and this side is also convex. Yeah, that's a cool question. Okay, more? Just for questions 13 and 14, right next to them, solve graphically. You really need to know how to read graphs about increasing, decreasing, critical, maximum, minimum. Graphically, where a derivative is undefined, on a sharp corner, on a point of discontinuity. Now we have 3 more questions. The answers are not available. You can write the answers as we solve them. Again, we're going to use the second derivative to find maximum, minimum. Question 15. And find maximum minimum, so we start with derivative. F prime x equal to, how is the derivative of square root? 2 square root goes down. Derivative of inside is 2x goes up. Now 2 cancels 2. I have x over square root x squared plus 1. Now to find critical, I can only take the numerator equal to 0. X equal to 0 is directly critical value. Denominator cannot be 0. And if I only want to find maximum minimum, I don't care what makes denominator 0. Unless this value that makes numerator 0 makes denominator 0 as well, then it will be vertical asymptote. Now, testing for 0, we need to find f double prime. F double prime x equal to, this time it's quotient rule, denominator power 2, the radical goes away. X squared plus 1. Denominator again, square root x squared plus 1. Multiply by derivative of numerator is 1. Minus x multiplied by derivative of the denominator. Derivative of the denominator, that's radical, so 2 radical goes down. Derivative of inside is 2x goes up. Now 2 cancels 2, but I don't really waste time on simplifying. You know why? Because there is a value goes in place of x, then no need to simplify. X is going to be 0, so this will be 0. Let's change the color. This will be 0, this will be 0, 0, 0, 0. This side is completely 0, it's gone. And here we get 0 plus 1 under radical. That is just 1. Multiply by 1, still 1 over 1. Result 1. 1 is positive. Positive means second derivative positive means f is concave. When f is concave, this critical value is going to be minimum. So x equal to 0. If x is 0, if I want to make this a point, put 0 in place of x, square root 0 squared plus 1 in f, that's going to be 1. Now as point, 0, 1 is going to be minimum. So the flow is like this. We started here, found critical, found second derivative, input, we get the result is positive. Now we know, what's wrong with this? Now we know f is concave. If f is concave, make the critical value point. Finally, the point 0, 1 is minimum. Easy stuff. Question 16 is also a very easy question. To find maximum or minimum, we begin with first derivative. F prime x equal to x is going to be 1. 4 over x is x squared, negative 4 up. This is the second derivative. If I say, that's the first derivative, sorry. If I say first derivative equal to 0, then we're going to say 1 minus 4 over x squared equal to 0. Send 4 over x squared to the other side, that will be positive. 1 equal to 4 over x squared over 1, cross multiply. X squared equal to 4, x equal to positive negative 2. Now we have two critical values. Put the critical values into the second derivative. Now second derivative will be f double prime x equal to, derivative of 1 is 0, just gone. Negative 4 over x squared is going to be the power multiplied by m, it will be positive 8 over x power 3. Positive 8 over x power 3. That's nice. Put 2 and negative 2 into the second derivative. f double prime of 2 is 8 over 2 power 3, that's positive. If f double prime is positive, f is concave, that means x equal to 2 will be minimum. And if we put negative 2, f double prime negative 2 is 8 over negative 2 power 3. That's equal to negative 1. If f double prime is negative, f is going to be convex. That means x equal to negative 2 is creating maximum. If we make a point out of it, just put 2 in place of x, up, we will get like 2 plus 2, that's 4, it's minimum. And if we put negative 2, we'll get negative 4, that is maximum. Question 17, let's do 17. F prime x equal to, derivative of cosine is negative sine x, derivative of x is 1. Now negative sine x minus 1 equal to 0, negative sine x or 1 to the other side, negative sine x equal to positive 1, multiply everything by negative 1 to make the sign positive, sine x equal to negative 1. Now take sine inverse, shift sine negative 1, that's negative 90, x equal to negative 90. Question 17 does not have interval, but there should be something like 0 to pi. Add the interval to question 17. Without interval, we cannot solve trigonometrics because they do have an infinitely many points of inflection. They do have infinite number of maximum and minimum. So an interval should be given to restrict the answers. Now I want sine to be negative 1. You can memorize this. Sine is 0 on 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. If you know this, that would be good. If you don't know, there's another way using calculator. This is called the test method, all right? Or we used to call it filtration. Let's filter this x to find some other x that are accepted in the interval. We just do simply 180 minus 90, 180 plus 90, 360 minus 90, 360 plus 90. This is the filter. Every value you get from the calculator using inverse, that value we added to 180, we subtracted to 180, we added to 360, and we subtracted from 360. Here we get answers if a value is repeated, we accept it once. Now 180 minus 90 is positive 90, 180 plus 90 is 270. 360 minus 90 is 270 as well, that's repeat, don't accept it without testing. And 360 plus 90 is 450, 450 is exceeding the interval 2 pi, 2 pi means 360, it is exceeding. Now I have two x values, I need to test, see which one, if I do sine, I'll get negative 1. So this equation is the main equation that we choose the possible answers from. Now using calculator again, you don't need to memorize anything. Sine 90. If I get the result negative 1, then I would accept 90. If no, I reject it. 90, I did not get negative 1, that is rejected. Now let's check for 270. 270 makes sine negative 1, that is accepted. So x equal to 270, or if we write it in terms of pi, 270 divided by 180 as fraction is 3 over 2, that is 3 over 2 pi or 3 pi over 2. For calculation we do use the 270. Now we need second derivative to check this critical value if it's maximum or minimum. Second derivative, first derivative is negative sine x, so second derivative f double prime x equal to, Derivative of sine is cosine, the negative stays. Derivative of minus 1 will be 0, we don't accept it. Now, f double prime to 70 is negative cosine to 70. Negative cosine to 70. That's 0. If the second derivative is equal to 0, this way is not efficient to say if the critical value is maximum or minimum. It's not maximum or minimum. Instead, it's critical and it's point of inflection at the same time. Question 17 is complete. This idea is complete, using the second derivative to find maximum or minimum. Okay. Here we have some relations between derivative, the graph of derivative, the graph of function, and the graph of second derivative. I would make this one separate lesson. This is the end of this lesson. Next lesson, we're going to explain the relations between graphs of f, f prime, f double prime, which is extremely important. Very, very important. That's why I want to make it a separate video. So if some of you want to save it or something, you have everything about relations between graph of f, f prime, f double prime in one video, which is the next video. Thank you so much for watching. See you soon.